Well, the next question is, why did you let Adam beat you on that four-jaw competition? So let's just say, it's about confidence building. These younger guys, sometimes they need a little bit of support and a little bit of encouragement. So it's up to us older guys to let them have some victories once in a while. Anyway, all kidding aside, he spanked me pretty good on that, but I've been practicing. So a lot of guys noticed that I took the six jaw off, and I've kind of gone to a four jaw. And so yes, I have been practicing. Am I getting better? I don't know, maybe. We'll see. That was a lot of fun. Meeting Adam in person was pretty awesome, and we hit it off right away, which was to be expected. What you see on camera is what you get in person, so you can rest assured that we are not acting. Okay, this is who we are. So listen, this will lead into the next thing. I get a lot of questions about parting in the lathe. Okay, so I'll bring you in a little closer, and we'll look at some parting tools real quick, and just talk about the things to look out for, and just give you the four things or 4 or 5 things that you really got to look out for, and then you just got to try it. Okay, so let's get in a little closer. All right, let's start with this. I use a variety of parting tools. Okay, so these are both inserted type here. This is a narrow one, and this is a little wider here. So I think this is, I can't remember how wide that is. 2 millimeters, and I think this is 3 or 4 millimeters, something like that. This is an ISCAR. There's the number, guys. Look it up yourself. This is a retrofit that fits in an Aloris tool block. Okay, so you don't have to buy the whole shoot match with that one. And then this is an ISCAR also, but it's just a small one with a shank on it. This one doesn't have a lot of reach, so this is kind of a special one there. This one here is high speed, and you can kind of see how it's sharpened. It's at an up angle, and if I put it in front of the camera, so it's kind of coming up at an angle, and then it's relieved underneath, and then there's a secondary angle under here to make that edge nice and strong. Okay, this needs to be ground square with the world. Okay, you don't want this at an angle because that pushes it off sideways. There are cases when you do put a little angle on that, when you want the pip to be on one side or the other. But in general, just make it straight when you're practicing there. Okay, and you notice how much these are sticking out. That's an important feature too. Or important consideration, I should say. All right, so let's put one in a tool post, and then we'll talk about the important stuff when it's in the tool post. All right, so here's our theoretical victim here. So, a couple things. So I already mentioned the stick out. You don't want any more sticking out than you need to do the job, okay? So long equals flexible, short is stiff. The second thing is this really wants to be square to the rotation, okay? So it wants to be square, all right? And you can't just eyeball this. You got to do a good job of it. You either face something off and put the blade up against that face surface. You put it against the chuck jaw to gauge if it's square, or use something like this to make sure that it's square, but it needs to be square, okay? If it's not square, you're going to have trouble, just guaranteed, okay? So the other thing is the tip here wants to be on center. You don't want to be high. You can be a little low and it still works, okay? But in general, start out on center. Don't get fancy. Just start out on center, okay? But just make sure you're not high. If you're low, up to 10 thousandths low, it's probably okay. It depends if you're parting off into a hole or parting solid material, okay? Next thing is when you're feeding, okay? Actually, maybe, okay, let me, maybe I'll make some cuts here. And put it into a better gear here. Actually, you know what? That's too fast. Let's try that. And it's too slow. That's good. That's a little better. Okay, so what I want you to do is I want you to look at the chip formation. All right. So, well, it's actually working here. So, you see, it's making curls, okay? That's a good thing, okay? If it's making kind of little segments or I don't know how to describe it, fragments, okay? Not curls. It's not curling like that, okay? You need to feed it harder, okay? So I'm going to increase the feed rate. You see the curls? That's what you want to see. You want to feed it hard enough to see curls coming off. All right? All right. If you're seeing dust, or tiny fragments, your setup isn't rigid enough, or you're not feeding it hard enough, okay? So I'm feeding, and you hear the machine loading up. You want to load it up a little bit, okay? Most people chicken out and they don't feed it hard enough, okay? This is easy material here. This is 1144 stress proof or whatever, so you can hardly do no wrong on this. So, but see, you get a curl going like that. That's what you want to see. That's a good feed rate there. All right. So if your chips look like what comes off of brass, little shards and little fragments, you're probably not feeding it hard enough. Okay. The other thing. Actually, let me turn it off so we can hear. The other thing is you really want to keep that cut wet. Okay. You want to get liquid down in there, oily oil or soluble with water and whatnot. You want to keep the sides lubricated and the whole thing lubricated, okay? As the deeper you get in there, it's rubbing on the sides, right? So you really want to keep that free flowing and the chips flow out of it. And the deeper you get, the more important that is, okay? And those are my Tom's words of wisdom on parting. Tom's Techniques did a really good video on parting. That's why I haven't done one, because he did a kick-ass job on a parting video. So go look at Tom's Techniques. He did a really good parting video, and he covered all the bases. I had nothing to add to that. Okay. So while we're on the subject of little devices that I've made, I drug a few more things out for you guys to look at. We'll do these kind of one at a time here. Let's do this one first. This is something I made for my wife. She was doing a lot of oil painting it, and she was making her own stretcher frames. So she wanted something to, she was putting them together out of this Douglas fir, 1x2 stuff. And she had to drill these holes, and hand drilling them was just kind of a pain in the neck. So anyway, I made this thing here. And the idea, let's see, I don't have a, let's just pretend this is some 1x2 here. So you'd stick the 1x2 in here like this, and there's a little stop pin in there. And then you can crank this down. And this is it's a right-hand, left-hand screw, so it clamps and automatically centers about these two drill bits, right? So it's like a doweling jig at some level. Now, the cool part about this is it all sits in a drill press, right? And then you connect the drill press to this, and both of those drills rotate in the same direction, and they have, come on Tom, turn the thing so these guys can see. They have little countersinking bits on there too, and then these are just, simple depth stops, and it's kind of linear bearings, right? So it moves up and down. So she'd stick the wood in there and go, and just drill them, and you got two holes that are perfectly in the correct spacing so it doesn't split the other piece and all that. So it was a fun little project, and she used it for a while, and then actually started buying her own stretcher frame. So, well, there's that bit. So that's the kind of stuff I really enjoy making. Here's another one. This one here is it's for coiling tubes, and so it's like a roll, you know, a 3-roll assembly, and this knob moves this roll in relation to these other two. It clamps in a vise, okay, and then you can rotate this here, all right, to put a tube through. And we were making helical cooling tubes, and we had to make a lot of them, so we actually modified the original tool to do that. These little side rollers here, you can adjust the height on them. So you roll through, and then you get the end started in there, and that lifts it up, and that sets the helix angle. So this sets the radius. When we move that in and out, that sets the radius that you're coiling, and then this sets the helix angle here by moving this up and down. And there's a spare roller. Oh wow, look at that. So I guess we made a lot of these. Look at the wear on that aluminum bit. I never noticed that before. So so anyway, that was a little tool that we made to do a particular job, and it was fun, you know, fun to make. So, and tube coiling deal. All right, let's get that out of the way. Let's go to this one here. Now this is kind of interesting. This is a sheet metal tool here. What this is this is a, it's for tipping the edge of sheet metal along a curve. So it's a tipping wheel, we call it, and uses a urethane, this is a pallet jack wheel here that's got a V-groove in it. So you run the sheet metal through here, and so say you had a circular part and you wanted to turn that, the edge of that circular part up, right? So you'd scribe a line in there, and you would follow that line. Hopefully we can see this, and you can feed it through with the handle here, okay? And then you can adjust the amount of tip that you're doing with this knob here, okay? Now this is nice because it's conforming, right? It's hard enough that it'll form, you know, most sheet metal, you know, as long as it's not too thick. This will do like 16 gauge steel here or something like that. It's hard enough that it'll form the metal, but not so hard that it puts scuff marks on it. So, and once again, this fits in the vise, and it's a hand-operated tool, and so you follow the line, and off you go. So, this was inspired from a friend of mine, Ray Schleen, who does Pro Shaper Tools. He's on the Instagram and Facebook and on eBay too, and he teaches classes. But he did something like this in his English wheel, and I took that idea and made it into a little compact assembly here. So anyway, this is the kind of stuff I love building, little devices and little machines, and it's just very satisfying work. Okay, so another good question that came through, or at least I thought it was a good question, is somebody asked about some U.S. patents that I have. And yes, it's true, I have several patents. Several of them are related to the design of a barbecue. Some of you may have seen the Kingsford barbecue that looks kind of like an egg. I built the very first one of those, and I have several patents related to the design of that, and in particular there's a very unique hinge that the lid rotates back on. So that's one of the patents, or several of them actually. And then I have another one for a supercritical carbon dioxide cleaning method that I developed some appliances for holding samples while they get cleaned with basically liquid carbon dioxide. So particular pressures and whatnot, carbon dioxide becomes basically like a solvent, and you can clean fabrics and all kinds of stuff with it. So it's kind of a unique thing. And then one of the other ones is related to what we see here, which is an anchoring device, basically. And what this is I developed this with a friend of mine named John, and it's called the Beachlock. That's what we called it, a Beachlock. And the idea is that you go to the beach and you go scuba diving or something like that, and you got you drag all your junk down to the beach, right? And you don't have any way to secure it. So you either got to hike all the way back to the car and lock your stuff in the car, or leave somebody on the beach to watch your stuff or whatever. That was the general idea. So this was a way to provide basically a place that you could secure your gear to. Basically an anchor in the beach. Think of a pole cemented in the ground that you can put a lock around. So that's what this is here, and basically it has a little helical screw at the bottom. Okay, so you go to the beach and you screw this down into the sand like that, and then it has a little clutch arrangement here that you can retract and stick a lock through. Okay, and what it does is actually, let's just do it. Yeah, so it's supposed to be in the ground there. So you put a lock through it like that. All right, and now you can't unscrew it anymore. Okay, it declutches the helix here. Now I know a bunch of guys out there are going, oh, well, come on, man, you just dig that damn thing up. Well, it's actually an interesting thing. This thing, even if it's embedded only this far in the ground, it'll take something like 2,000 pounds to pull it out. I don't know about you, but at the beach, if I had to dig 4 feet down, basically that's a cone of sand that you have to remove. That is a considerable amount, and we tested that. Okay, so after 20 minutes of digging, 2 guys, we gave up because it was too much work. You're better off attacking the lock and cable than digging this thing out. And the interesting thing is, this all ties into some other stuff, but you guys have seen the tomometer. Well, we created that tomometer to actually pull test these things here. And we built a small version that only went up to, I don't know, 1,500 pounds, and we immediately exceeded that one. So we built that second one that was good to 5,000 pounds, and we exceeded that one. So basically, the mode of failure, it turns out, is these welds breaking on the helix and it ripping the welds loose from the helix. The helix is not coming out of the ground, trust me. We tested it. This is a slightly different version here. This one here breaks down so that it stores in a shorter way. So anyway, that's about my patents, and so a couple devices that I got patents for. So this was fun. This was a huge learning experience, and we didn't sell any of them. I mean, I think we sold 3, and but it was a huge educational experience into developing something to manufacture it. Going through that process to get it patented properly, and so extremely educational. So I wouldn't give up the money and time that we spent on it for anything. So it was pretty good. Okay, pretty cool, huh? Okay, so I hope you guys are enjoying Meatloaf 100 so far. So we'll do some more kind of verbal questions here. Somebody asked, what's the biggest screw up you ever did? And when you're doing this kind of work, you're kind of always screwing up a little bit, okay, here and there. This is how you learn, okay. But one that sticks in my mind, you know, and of course it's when you're the new guy in the shop, right? It was a sheet metal shop I worked at in San Francisco. The boss, he gave me a fab order for cutting up a bunch of 11 gauge stainless, okay? You know, which is fairly, I don't know, fairly expensive material. It's several $100s per sheet at least, okay? The job was to cut a bunch of squares of a particular size, right? And so I said, okay, great, you know, give me the thing, right? And he goes, oh yeah, there's a skid of material up there. So basically, you know, it was a stack of sheets, you know, I don't know. There was probably 20 sheets, something like that. I don't remember. It was a lot. It took a while. It took a while to screw up, okay? So anyway, he gives me this job, and so I go to town on it, right? And so I set, those of you that are familiar with power shears, I set some front stops on the shear so that I could put the sheet through, pull it back against the front stops, shear, and then rotate, shear, 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 right? And then shear against the back gauge. It's called stripping and blanking, okay? So anyway, I get all set up, I'm a happy camper, and bangity, bang, 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 right? I don't know, maybe I'm halfway through this thing or something, or more, I don't remember which. I go behind the shear to clear some of the stuff out, right? And restack it on a pallet, right? And I happen to put my tape, check your work, right? That's the lesson. There's always a lesson, right? So I put my tape measure on there and went, oh shit, you know, and you get that whoop in your gut, right? That feeling that comes up, right? And I went, oh my God. And so I checked some more, and it's like, oh no. Well, what had happened was one of the front stops, you know, this is a 10-foot shear, right? One of the front stops was about an inch different than the other. I think the tape measure, you know, I analyzed it later. I think the tape measure caught on the shear blade, and I inadvertently burned roughly an inch, right? So, you know, I realized I really frickin' roached this job, right? And so I go up to the boss and I go, hey, and he goes, what? And you go, I said, and here's what I said. I said, I have a little problem on that shearing job. And he wasn't looking at me, and he turned, and without even turning around, he goes, there are no small problems on 1/8 inch stainless. And I just went, ugh. So the stomach did the thing again. Anyway, he said, well, let's go look, right? So we went over there, and he goes, oh yeah, no big deal. I go, what? Well, it turns out, and I didn't know this, that we were going to cut circles out of those squares later on, and there was a fair amount of extra material on it, and the diameter of the circle, even if one side of the square was an inch short, you could still get the circle out of it. So it was just like whew, complete relief. And so that's one that sticks in my mind. I don't know if it's the biggest one, you know, from a money standpoint, but that's certainly one that sticks in my mind. I chuckle about it when I think about it because I still get that feeling. Terrible. All right, so I got a couple more Tom inventions that you guys might get a kick out of that are worthy of a number 100 Meatloaf. Let's look at this one first. This is basically a pile of prototypes here from testing and whatnot. And what these are, I call them Bearhooks. And it's for backpacking. So some of the backpackers out there, if you backpack in bear country, you need to secure your food and your smelly stuff out of reach of bears, okay? Well, if you've ever had to deal with that, you know, stringing a rope up in a tree and, you know, looking around for an hour to find the proper branch, and then getting a line tossed over it, and then hoisting your stuff up so that you can get it secured out of bear country, or out of the reach of a bear. it's a pain in the neck, okay? So I said, geez, I said, you know, what would be an easy fix for this, right? And I said, you know, there's usually plenty of trees, okay? That's one nice thing about it. And I said, you know, I don't want to climb the tree. How do I do this, right? Well, I designed a set of hooks here that you can actually hook over even a fairly small branch, okay? So the idea is you find a couple of trees that are the right distance apart, which is pretty easy because they only need to be about 10 feet apart. And then by using your trekking poles, which most folks are carrying these days here, all right, you can put two of these together, all right, so that's that's 4.5 feet, and so that's 8 feet, and then another 7 feet. So now, by just sticking this is a little mini version here, by sticking this on the end, and it's got an eyelet so you can string a line, I can reach way the heck up there and hook that on a little branch, okay? And now I immediately have a line going between two trees that's over 10 feet off of the ground, okay? And so now it's a simple matter to basically just hoist your food up and secure the line and you're done. So, you know, you just go 50 or 100 yards from camp and you do this, and, you know, if the bears come around, good luck, right? So they're made out of sheet metal. 2024, a real high strength aluminum alloy. The tricky part was forming this little pocket here that fits the end of this. So there was a bit of development work to get that to work. So anyway, that was another little Tom invention. Like I said, this is a pile of failed prototypes here. I use these to this day. I have a pair in my backpack that I use. Never really marketed them or did anything with them, and gave away a few sets to friends. And but other than that, that's as far as it went. Maybe that's a good Kickstarter project or something, right? So that's the Bearhooks. So the next one, actually, let me reposition the camera because this will be good. So all right, so the next one has to do with cameras, and this is my old digital SLR here. Unfortunately, this one is just before they started doing high definition video with these, right? It's an Nikon. My little invention here is this thing I call a Quickdraw. And I don't know about you guys, but I despise neck straps. And in particular with a heavy camera like this, it's terrible. So the way this works is this actually just fits in your belt like that, and it's actually secure. You can run with it, you know, you can run with it, and boom, you can pull it out and get the shot. That's why it's called the Quickdraw. And it's quite comfortable to wear. The other place you can put it is you can put it on the sternum strap when you're backpacking, and it's right in front of you there, and you can just and you take a shot. This is threaded so that you can still put it on a tripod or put a dovetail mount on there and put it on a tripod. It's made out of stainless steel. It's formed up. And look at that. It makes a little base you can set the camera on. It's got it in spades. So anyway, that's the Quickdraw. This is one of my favorite things because I used the hell out of it when I was dragging this thing all over the place. Now, you know, your phone's pretty good now, and certainly a lot lighter than this beast here. So the Quickdraw. All right, let's do a couple more of these questions and wrap this deal up a little bit. So actually, quite a few people have asked me about the old buildings in the intro and outro of my videos. I mean, I've used various ones. In the over 380 videos that I have, you guys. So it was funny, you know, I was looking at some of them the other day, and yeah, I get quite a few views on the newer ones now, but the older ones are still actually pretty low view counts, even though they've been out for a couple of years. So what that means to me is guys aren't going back into the archives. So I need to find a better way to drive people, not drive, but to interest them in going back and looking at some of that old material. Now, there's some gems in there, I guarantee it, okay? And 380 videos of roughly 30 minutes average length apiece, that's a lot of content. So anyway, go back in the archives and poke around, or just use some search words in the on the front page there. There's a little magnifying glass icon, and search for something that you're interested in, because we do use keywords and tags and things like that. So anyway, somebody asked about these buildings, these old buildings. So something I always like doing is exploring old industrial sites, abandoned industrial sites, things like that. So a lot of those pictures are either from Hunters Point Naval Shipyard, and the current ones that I'm using are the outro is the steel shop at Hunters Point, and the intro is a little side building that was near the old Todd Shipyard, T-O-D-D, Todd Shipyard in San Francisco. It was a foundry building or something like that, I don't remember, but I was snooping around one day and drove back in there, and you know, you could walk in, there was nothing in there, you could walk in there and there's an old crane in there, and it's just kind of this old abandoned industrial stuff that I kind of like. So anyway, that's the story on those buildings. So okay, so that's that one. What do we got here? Oh, some guy asked, he said, hey, I noticed that, you know, when you face in the lathe, sometimes you start at the center and you come out. And I said, you know, I said to myself, really, I do that? And but in thinking about it, yeah, I do that. And so it's a time-saving thing, okay? So if you got a bumpy face, right? You can start at the outside and feed in, and then wind it back out, and then start at the outside and feed in. Or you can feed from the outside, you can feed from the inside, you can feed from the until it cleans up. So it's just a time-saving thing. Also, I might do it if I intend to poke a hole in the end of the rod. So where that center really doesn't matter very much if it's perfect, right? You know, you're going to center drill it and bore it or whatever, right? And who cares if it's got a little crown in the center, right? What you care is that you've got a clean, smooth surface, right? The rest of it. So yes, I do that, and it's really just kind of a time-saving thing. So if you watch old guys, these are the kinds of things you pick up. And you know, if you were doing a whole pile of 150 millimeter or 6-inch rounds, that old guy would stomp you in the dust if he was facing in both directions and you were only facing in one direction. So anyway, just a little point there. So so the next one here is actually pretty good. It says, I notice of late that you're giving metric measurements in your various demonstrations along with the imperial measurements. Does this indicate a possible shift into general acceptance in the U.S. engineering industry for the use of metric measurements? So what I have to say to that is, are you kidding? No way. So it's mainly for my European viewers. It just helps them follow along. Also, in my work, I have to constantly switch between units. The physicists and scientists are definitely all metric, although they're very good at bouncing back and forth as long as you tell them what the units are, and they don't have a problem with it. But at work, it's mostly metric stuff, and at home, I mix it up a little bit just to answer that question. So, is there a shift in U.S. engineering? Yes, it's pretty slow though, and you know what? I have no good excuse why it takes so long. All I know is there's no return on investment for U.S. industry. So if you have a $2 billion steel plant that's all set up to do all your calibration, all your infrastructure is set up around inches and feet and all that, and you just suddenly flip the switch and now you want to go metric. It wreaks havoc with all of that, and who's paying for that? The consumer, because the government's not going to give you money to change your plant over, and so that plant really has to just be crushed into dust, and a new plant built where they do just start from scratch and build it metric. So, or yeah. Anyway, you get it. Okay, so let's go look at something else. Hey, I almost forgot. Hey, this is for Richard Westerfield. Yes, I heard your question. When are you going to work or finish your wife's etching press? I've posted this 3 times already. Thank you. We're going to get back onto that, Richard. Don't worry. She's on my case, and once I clear this baby bullet out of the way, we're going to get back onto the etching press proper. So thanks for your concern, and it's duly noted. All right, guys. Thanks for watching.